and welcome to Writing to Represent Scientific Knowledge. I'm glad you could join us. Before we begin, I'd like to draw your attention to the Submit a Question button. You have the opportunity to join our discussion by submitting your questions to the panelists. Do so early and we'll answer as many as we can at the end of the live webcast. You'll also find support materials related to today's topic, including the feature article, video tutorials, and companion mini collections. These materials can be accessed at any point during the webcast and will continue to be available on the Science Instructional Strategies, a look at the OGT homepage. Now I'd like to welcome our panelists. Director of Ohio's Evaluation and Assessment Center for Mathematics and Science Education, Dr. Sarah Woodruff, and science teacher at Beth High School and ORC's Science Review Board, Sylvia Clark. And Sylvia, I have to apologize, it's not Beth High School, it's Bath High School. Let's start by looking at the data and see what it has to tell us. Sarah?
Yes, Tara, I think we see both positive and unfortunately some negative trends in our data so far on the OGT. If you look at the results from 2005 and look at the results from 2008, we see on the positive side that students are responding to the constructed response items at a much higher rate. They are attempting to answer these questions, and that's very positive. We're very happy to see that. What we're seeing, unfortunately, is that though they are responding, they are not responding in ways that are helping them score more points. If we look at the students who score a 0, in other words, they have attempted the question, but they've not responded appropriately or at a level to earn points, those earned 0s have stayed pretty constant over time, and we're not seeing that students are earning more credit for their answers. So it's great that they're attempting questions, they're responding, they're trying, but they're not demonstrating enough science knowledge in their answers to help them score better. Okay, and it is very encouraging that we now have more students giving it an effort. They're trying, they're putting something down, but it's all, as you said, it's also discouraging that we've still got so many students scoring 0s. And I did want to point out that when you look at that data in that first column, those are no responses. So a lot of those we're seeing in the 2, 3, 4, 5% ranges, and then you get into the 0 responses, and a lot of times they're in sometimes in the 20% range. So what is it about writing that's so difficult? Why is this such a challenge? Sylvia?
Well, I think that, first of all, our students are used to writing in other subject areas, especially their language arts classes. They're not used to writing scientific. They're not used to using the terminology that's connected with science, and that makes it very difficult for them. If you're uncomfortable with the topic, with the subject, with the terms, then it's very unsettling to try to write about something that you're not comfortable writing about.
So students are focusing a little bit on memorization, you think?
I think the memorization is there too. They are very capable of memorizing. They just do not know how to take what they've memorized and apply it to real knowledge, to convert it into something that they actually know. They definitely have the ability to memorize, and they can regurgitate that memorized glossary, scientific term definition, but they can't put it into something in their own terms that helps them to understand what they're actually what the real science is.
Okay. And are they making connections between those different discrete memorized facts?
I'm not sure that they are. It's jagged. I think it's disconnected. It's a little bit here, a little bit there, but they don't have it together as a full piece or a full puzzle. It's just some pieces over here and some pieces over there.
Yeah, that's a good way to describe that it's jagged. Sarah, what would you like to add?
I think Sylvia's hit upon something really important, which is this idea that students, they know science content. They have learned some science facts. But on the OGT, we know that we see items across a variety of cognitive demands. So we're requiring students to do more than just tell us, regurgitate or tell us back what they've learned. Those 4 cognitive demands are recalling and identifying accurate science. Typically, we don't see too many or any constructed response items that are at that level of cognitive demand. We do see items from communicating, understanding, analyzing science information. Mm-hmm. Those items would typically include maybe a graphic representation, something data that needs to be interpreted, and students would have to then communicate their understanding of that. Demonstrating investigation processes of science is another cognitive demand that we would see quite frequently in a constructed response. And again, those are tied to experimental scenarios or real-life types of scenarios that the students would be asked to respond to a task. And then applying concepts and making relevant connections in science, it really gets kind of at the heart of what Sylvia is saying, that kids need to be able to apply, they need to be able to connect. They've got some sort of disconnected science knowledge, but to be able to put that down in writing on an assessment has been a challenge for them. I think a great example of that is an item that you see on your screen that was from the 2005 graduation test. And what we see here, first of all, students are presented with a diagram as a piece of information that they need to interpret right up front, and they're provided some information around that. And obviously there is life science content in this question, and a good deal of content, but possibly things that students have learned not connected to each other. But what this task is asking them to do is to bring together all of those pieces. They need to understand the pedigree. They need to know concepts of heredity. They need to know what a Punnett square is. All of these types of things. They've got to bring that all together. So they can do that in a couple of different ways. They might choose to just represent that via a diagram of their own that's labeled. That would be a perfectly acceptable answer to a question such as this. Or they might just choose to write text. But there are the point really is that the kids can respond in different ways to a task and be absolutely accurate in doing that. But they need to have an understanding, a conceptual understanding of the concepts, and not these little isolated kind of factoid things that sometimes they bring to the table.
Yeah, so it is a big idea. We need to put those pieces together, absolutely, as you said, with a conceptual understanding of this big idea to get the whole picture of the concept that we're talking about. So we know that more kids are trying to answer the questions. We know that they know science facts, but we're still having trouble with the writing. So what are some things that science teachers can do to help students become comfortable and proficient at writing to represent their scientific learning? Sylvia?
Well, an example of one of the activities that I do in my classroom has to do with cell identification. Students will look under the microscope. This, of course, after we've had our lesson on cell structure and what their jobs are. They will look at cork cells. They will look at a slide of prokaryotic and eukaryotic cells, which are mostly bacteria and epithelial cells. They'll look at squamous epithelial cells. And between those three, they'll make some diagrams, and I'll ask them to identify structures, possibly even identify structures that they know they can't see, but they know that they're there. They will then also take a look at an Elodea leaf, which is a live plant, and which some of them may actually even be familiar with. So this is a living cell structure, and they see moving chloroplasts, which for many of them is the first time they've ever seen anything like this under the microscope, let alone see something moving to represent that it is living. We also take a look at photographs taken with the electron microscope, where they're looking at the structures that they can't see. So there's also measurement in there, size measurement in terms of how small these structures are in comparison to what we're comfortable with, or what we have seen under the microscope. And then to kind of wrap it all up, I ask students to write a paragraph, hopefully 4 or 5 sentences, that will explain and connect all of what they've done here. They've looked at plant, they've looked at animal, they've looked at prokaryotic and eukaryotic. All of these terms are being thrown and should be kind of combined in here, coupled with perhaps maybe some of the structures, mitochondria, nucleus. And I ask them to write a paragraph about what they have observed in this particular lab, which takes about 2 or 3 days for them to accomplish. So getting them to write about what they have observed. They're observing, they're making notation, they're making drawings, and then they're going to write about what they actually see, making it all come together, hopefully.
So within that paragraph, you're really asking them to write some evidence-based share some evidence-based information, to use accurate scientific terminology, and to really express what they know about the concept.
Understanding that what they're looking at, it is specific, so it's not arbitrary. There are specific things that they should be looking at. Even though you may not be able to see all these structures and all these cells, you are looking at specific things. So there is a connection there. There is that connection.
And we know that in their English language arts class, they write that paragraph and it flows and it goes so well. But yet when we ask them to draw on that scientific evidence, they struggle.
They do. Again, being uncomfortable with the information, being uncomfortable with the terminology. Although some of these terms they have had through their previous years in science, it's still not something they don't go around talking about prokaryotic and eukaryotic. I'm prokaryotic, I'm eukaryotic. So it's not terms that they're comfortable with. Therefore, writing about it isn't easy for them. So it is a process.
Okay, great. Sarah, how would you like to build on that?
I think what Sylvia brought out is very important, because what she's providing us here is a very rich set of activities. In the context of a learning cycle, students need to have the opportunity to engage in writing tasks throughout that learning cycle. Not just we get to the end and she's not asking them, get to the end and write this paragraph. They begin with some really concrete, we're going to do diagrams, we're going to label diagrams, we're going to begin then to connect ideas across different types of cells. So developing a conceptual understanding, and at each of those points in the learning cycle, representing your learning. So you're diagramming, you're labeling things, you're writing, then you get to a more summative kind of activity, and you've got to pull these pieces together and produce something that then is demonstrating a more sophisticated level of understanding.
So I'm glad you brought the learning cycle up. We know it's such a research tested. We've got lots of research that says this is a wonderful strategy for incorporating inquiry into the classroom. Are there some writing tasks that are more appropriate at different phases of the learning cycle than others?
I think there are tasks that lend themselves more naturally to different phases. The really critical thing to remember is that during each phase there should be some opportunity to represent learning. But does that mean kids have to write everything all the time? No, there are a variety of ways to do that. For example, during an engagement activity, as Sylvia mentioned, here they're diagramming, but perhaps they would do a quick write of everything they know about cells. Only you give them 2 or 3 minutes, so they're quickly documenting things that they know. That provides a couple of things. One is the opportunity for the teacher to look at quickly, reflect on what the student's written and plan instruction around misconceptions that might emerge, those sorts of things. And then it also provides something the student can keep revisiting and building upon. During an explore phase, it's great to use a KWHL chart where they begin, with what they know, and they're building, through that phase. And then as they're explaining, this is where we really would hope that they begin to use the terminology to express their more sophisticated understandings. Perhaps they are at that point writing something, as Sylvia has demonstrated for us, that would bring together the concepts, and then the teacher again is kind of intervening and guiding that instruction through that phase.
Okay, let's look at this idea a little bit more. The learning cycle is such an important part. Can you give me another concrete example in which you walk me through an engage activity and give me some clues as to some writing tasks we might do there?
Sure. Well, I would pull from physical sciences, as that's my background, and I think about forces in motion. We study forces in motion quite a bit in the high school, and I could imagine a teacher possibly up in front of a classroom, and they've got a skateboard, which would be an interesting engagement for most students. And the teacher might ask the students to, if there's going to be a demonstration, and ask the students to diagram, perhaps produce a label diagram to write about or to represent their learning or their observations of what's going to happen next. And the teacher might step onto the skateboard and step off. Obviously something happens related to forces in motion. Students would make those observations. Possibly then have a chance to kind of dialogue about what they saw and the ways in which they explained it. And you can then go beyond that into explore and helping them think about how might we learn more about what we just saw. And the teacher might ask students to predict. Again, another important science process. The students might predict what would happen. What if two people stood onto the skateboard, stepped off in opposite directions? a prediction about what they might see at that point in time. I think the issue really is to make it very authentic and to just keep allowing students to build upon their representations and to not always feel like there is a right and wrong. Students, I think, part of what we might see, not only on the assessment, the statewide assessment, but in classrooms, is that students are hesitant to express their ideas if they don't feel their ideas are absolutely correct. So providing them lots of opportunities to do that and understanding that we certainly will go back and revisit our ideas and that they will become more accurate over time, but that it's not necessary that they would be right all the time.
That's a really good point about the need to be right, that sometimes as a teacher, when we ask students to write and we collect that and we look at it, finding out what they're writing that is incorrect provides us with an awful lot of insight into student thinking. So Sylvia, would you like to add to this?
Yeah, and I think Sarah had brought up some good points here about getting the students to write on a regular basis. And for teachers out there, just because students, you may ask your students to write scientifically, be it in a journal or some type of a report or paragraphs on what they've observed in a particular activity, it doesn't mean that we have to grade everything extensively. I think that there are ways to take a look at the work and write through it. You can pretty much glaze over it and tell very quickly if these sentences are connecting and or if they're just 4 or 5 statements out there. So I think that's a good point too, is that we need to remember that we're not really asking teachers to take on a lot of work here, but you can read through and glance through the work and not bog yourself down with a whole lot of writing that you have to read.
Yeah, right. How important is it to provide some feedback to the students when they've completed a writing task?
It's really important because, again, the whole point here is to help the students to realize it's not enough just to write 4 or 5 sentences. It is important that these 4 or 5 sentences are connecting to an idea, to a content that we are trying to address at that point in time. So you have to let the students know if they are making that connection. If they're not, you got to let them know so that they can come back and do better at it. Because ultimately, that's what we're trying to get them to, is to the point when they really have to write a well-written statement or paragraph, and it does make a connection with several ideas. So we do have to let them know what's connecting and what's not.
So we're giving them multiple opportunities to write on the same topic as well. And Sarah, you mentioned earlier about as you're moving through a learning cycle lesson and they're writing on the same topic, looking for that increased sophistication in their responses. So that's really good. And you said something, Sylvia, that I'd like to build on. It's not enough just to write. So will writing alone solve the problem?
No. I think that along with the process, we still have to go along with using the terminology. So we need to make sure that not only are they writing, but they are also reviewing the terminology and they're using it, which is one of the reasons why we want to give them the option to do group work so that they can share and help each other to build their scientific terminology, to build on the scientific concept, the scientific term there.
Okay, so when they're writing, there should be an expectation that as they become more comfortable with the scientific terminology, they should be using it accurately and in the right context.
Yes.
Okay,
yes.
Great. Sarah?
I think the data tells us that writing alone will not solve this problem. This idea of scientific discourse, I think, is very critical for teachers to understand. And scientific discourse is really about this evidence-based writing, that students represent their learning and that they are using evidence to do that. And when they dialogue, they're dialoguing based on evidence. That really is at the heart of this scientific discourse idea. And a great example, I think, of that is the item that you're seeing now on your screen from the 2008 OGT that provided, again, some stimulus that was visual. We do see a lot of that. There's a graphic there and there's text, and students need to evaluate evidence that's provided. and talk about the the validity of that evidence, and really kind of make a counter argument, a counterclaim, which is a part of scientific discourse, based on what they see here in this item. And again, the cognitive demand of this one is applying concepts, making relevant connections with science. So we see we're not strictly asking students, a knowledge level question about this particular concept. We're going, pretty far beyond that, and at a sophisticated level about this particular topic.
Okay. We've looked at a couple of released OGT items in our conversation today. So let's turn the conversation towards using released OGT items in the classroom. How can we use released OGT items in classroom practice effectively? Sarah?
Well, I think the really critical thing to remember, and it's difficult to remember, is that once the items are released, we do not see them again. Released items will not appear in that same form on another test. So being really strategic in how you use those, obviously they're a great resource, but being strategic in how you use those, I think, is important, because teachers have limited time and energy to do these sorts of things. But just strictly kind of drilling and killing on the items is probably not where we want to be at this point. Looking at the content, possibly using a stimuli that's pulled out of the, don't use the question, maybe the stimuli is great, and making sure that it's within the context of what the students are learning at that point in time. They need to be, I know it was common practice at the beginning of the OGT that, looking at an item every day. Well, that was great kind of as an awareness activity, I think, for both teachers and for kids. But at this point, that we want to move beyond that. We want to be able to embed it in the learning that's already happening. So being, picking and choosing how we use those stimuli and those questions, I think is a better approach that will probably yield us some better results.
Okay, great. And you mentioned the stimuli, and I think presenting students with lots of opportunities to interact with stimuli is an important thing. Sylvia? And
Sarah's right. I think we did start off trying to introduce these OGT items on a daily basis, whether they were connected to what we were discussing in class, the content that we were discussing at that point in time or not. So we're studying cells over here, but you're going to get a genetic question over here today because that's where we are on the factor. So getting rid of that, getting rid of the idea of dealing with this information on an isolated point. The whole point is we don't want our students to think of science in an isolated point or concept or content. So why should we put questions to them that are isolated and out of content? So we need to keep them in content. So as they come up, use them. I think one of the areas that was really good for using previous OGT items also is taking student responses that the state provides to us and maybe taking those 3s and 4s that represent what we want students to be able to possibly write for us, and putting them on the table and giving students in a group format an opportunity to look at both of these sets of responses, a 3 and a 4, and they don't know which is the 3 and which is the 4, discuss what's good and what's bad about both of these responses, and in their own process, in their own attempt, they are regurgitating, reviewing, and understanding what they are expected to write eventually on their OGT test by studying those and conversing. I really like that idea of looking at samples of student work that's been released by the Department of Education. It's anonymous student work. Nobody in the class wrote that, so it's safe for everybody to critique that work. And I think there's a sample question I think on the screen about recycling aluminum. This would be a great place to do that because students are familiar with the idea of recycling with aluminum and this whole concept. So then to look at a couple of responses and based on evidence, discuss those responses, that's a really great suggestion. I like that a lot. Sarah, is there another way we might use this in the classroom?
Yeah, I could see this maybe as a journal prompt at the beginning of an instructional unit. Quickly students will kind of write about their knowledge on this particular question. You might even be able to personalize it a bit and bring it back to the community level. What do they know about recycling in their own community or in their own homes? And sometimes the hook for kids is something that's a little more close to home. So, this is a great question, but maybe a teacher could even kind of expand upon it. And then both the teacher and the student can reflect back on that initial response to the journal prompt over time and build upon it and, help them understand how their learning is progressing as they go on.
Using these questions as a way for students to monitor their own learning, again, and journals are great for doing that. It's a great idea. We put this into the journal and then we can look at it. And then after we've had some instruction, we can look at it again and modify our response. So, and it comes back to that. Things get a little more sophisticated as we learn more. The personalization, again, great ideas. I think we can also sometimes use these as kind of a pre-assessment before we begin looking at the content, possibly incorporate some of them into learning cycle lessons, into inquiry activities. Lots of creative ideas and good uses for these questions. You guys have done a great job answering these questions. You just provided so much wonderful information to our viewers, but I think they may have some additional questions. So let's take some time. We've received several questions from our viewers. I'd like to share those questions with you and take a look at some of these questions and provide a little more information for our viewers. Is there something specific other than accurate science that I should look for in student writing?
Well, I know from a classroom teacher, yes. I think that it's still important that the students are using good grammatical format. So they need to understand that when they write in science, it's not jagged, it's not little notations here, it's not 3 or 4 sentences that have no connection. As a science teacher, getting a writing piece from a student, we still need to expect them to use good paragraph format, good development of sentence structure, and to have all the components of the sentence structure that should be there for that grade level that they're working with.
Okay.
If I could build upon that, that gets to the idea of clearly communicating. An important aspect of science is that scientists need to be able to communicate with each other. And so expressing yourself in a way that others understand is very critical. And the other thing I think that you mentioned just very shortly, or very recently, is this idea of developing more sophisticated understandings over time. So as you're monitoring the students' writing, what are you seeing over time that tells you that they are developing a deeper understanding of the concepts and connecting the ideas as they go?
Okay. Here's another question that I think is, it's a really important, because sometimes it's hard to stay fresh. Where can I get ideas for students to write about science? Thoughts?
Well, okay. Again, for me, every day in the newspaper, I tell my students that there's not one day that I don't read the daily newspaper and I find some kind of an article that is science connected. Of course, I don't limit them to a life science or biology subject. It is any area of science and technology, and it's just there every day. And this is not looking at for your information kind of articles or the Dear Abby kind of articles. Taking all of that aside, there is always something in the newspaper. So that's one of the areas I start with, current event kind of things. I ask students to write about current events, and that is what's happening every day in the newspaper. What's happening every day that's science connected.
Well, it puts it in a real world context.
Yeah.
Here's another one. If you had to pick one thing to do in the classroom on a daily basis, what do you feel would be most beneficial to my students in helping to improve their constructed and extended response answers?
I think we've touched on that a bit, but it really is the opportunity to write about the authentic experiences that they're having in science. I think what we do is we sometimes try to force the fit between science and writing, and that really isn't necessary. It's great if there can be an activity that lends itself to representing to learn every day. That there's some writing, there's some diagramming, there are opportunities for students to, to get that down on paper, because the research tells us that that is really critical to their learning and to their actually changing their conceptual understanding. So any opportunity to be able to do that, I think, is wonderful. But again, what we don't want teachers to feel like they have to do is to force, we have to write today. There are other ways to represent learning. Maybe there's just dialogue on that day. That's still a very positive thing.
Most definitely. We need to make sure that we understand that, like Sarah said, stop trying to force it. If it's not the day, if today's not the day that lends itself to writing something, a topic that could be written on easily or written on, then today's not the day to have a writing assignment. There's plenty of opportunity, and if your students are doing science, they're experiencing science, there's going to be plenty of opportunity to write. So save that for a day that they're going to have the opportunity to write on. It doesn't have to be a daily thing.
Right. And make sure they're ready to write on it. If they haven't developed enough of a conceptual understanding, it may be a little bit premature. And you said something early in the webcast, Sylvia, about writing a paragraph. It doesn't have to be something lengthy. It can be something that's fairly short, but they still have had a chance to write down. That writing helps them refine and clarify their thinking. It helps them organize their thoughts. And all those things really are very important towards working to conceptual understanding. Here's another interesting question. You say that students need to know the big idea, but the state grade level indicators pick out isolated facts to teach rather than the big concepts. How are we to teach the big concept when you have so many minor facts that are not connected? That's an interesting question.
That's a great question. I think that gets right at the point of the learning cycle. The learning cycle should be built around those big ideas. We hope that the grade level indicators provide some guidance on what are the facts and the things that, the scientific content that gets plugged in, but really building the learning cycle around the big ideas and constantly working from that as the framework, I think will provide more value to students over time. And again, going back to what Sylvia expressed earlier about kids they can memorize, and their brains are great at, young brains are great at those sorts of things. They can do those things, but we really hope to move them beyond that. And I think that the key is to just really build on those larger concepts. Like I said, the indicators are there, they provide guidance, but teachers know what that content is and what the real foundational scientific understandings that underlie those benchmarks are.
Well, and you hit on the key word there, benchmarks. It's the benchmarks that are being tested, and the grade level indicators really, as you said, provide some guidance. So I think it's a matter of looking at those and grade level indicators too, and putting them together in concept related pieces. And then filling in the blanks if filling the blanks is what needs to be done. Sylvia, did you have something to add?
No, I think Sarah's right. I think sometimes teachers get overwhelmed because they see the indicators and feel that these are the points that they have to get, and sometimes they don't see where the connection takes place. But it's actually the big benchmarks that are the big ideas, and I think if they cover those big ideas, then the little stuff, which are the indicators, should fall into place. So I think sometimes as teachers, we stress ourselves out over the little things, when if we look at the big picture, which is the big benchmarks, then everything kind of falls into place from that point on.
And to remember that the grade level indicators, this is not a checklist. Right. First, a compliment to both of you. These are great ideas, but give us something that is targeted for the unmotivated students. And then there's a big thanks. The challenge we all face in education, what do we do with that child who just simply is unmotivated to learn?
Well, okay, I'm going to harp on this. The learning cycle, the very critical part of the learning cycle is that you engage the student, and if you don't get that piece done, you may not make much progress. when students have an opportunity to represent their learning, the teacher learns from that. They learn what the student is and is not interested in, what their prior knowledge is, what their misconceptions are, those sorts of things. There are a lot of students who, unfortunately, by the time we see them in high school, are turned off of science, and that's very, very sad. Science is the most exciting thing in the world, and they should love it. But they, we can say that. But they some of them don't. So being really in tune with what might motivate your students, knowing that motivation is an internal thing, and the kids have to be able to grab a hold of something, but providing them as much as you can to grab a hold of, and personalizing it, getting at their interests. Kids typically like, they have a lot of self-interest at that age level. So being able to kind of get at their level. We talk about real-world experiences. Well, real-world experiences for an adult are not the same as they are for an adolescent. So contextualizing it within the real world of adolescence, and perhaps, we all have to get more in touch with what that is. But I think that that's the best bet for trying to get there.
And engaging them, there's a lot of opportunities to do that. There's some great videos online that you can look at, an image, a story, a newspaper clipping, but something to make the science real to them so they can see this is part of my life and this matters to me today and it will matter to me tomorrow. So, and the authentic experiences that you talked about. Okay, I'm going to do one more question, and then we're going to have to make some final comments. And I think Sylvia, this question is for you, and it's related to your example about looking for current events in science. So the question is, to what extent do your students write the abstracts?
I give them 3 guided questions, and it's set up where the questions that I ask them to, one is to evaluate, first of all, tell me what is this article about, not just the title of the newspaper article, but what's actually being addressed here. I ask them to possibly consider how this might impact their life now, or possibly family members. And then I also ask them if they have anything in their life that or background that could connect them to that. So was this article, perhaps maybe you have a family member that is connected to this, if they are looking at some type of scientific discovery, if you have someone that's working in the field on any kind of level. So I start off with 3 guided questions, and then I ask them to just simply write about that newspaper article. And it's amazing. Sometimes I get just a really little couple paragraphs of an article, and those students, that's the article that the students will write the most on, because maybe because the information is condensed form, so they can jump right in there and start writing about it. But I think that's pretty much how we do it. I start off with some guided questions. They got to have some kind of a marker where to start. But I think if you give them the right markers, and the thing about the newspaper article for me is that, and for the students, is that it is not, I'm not grading them on what they wrote per se, because that's their opinion. I'm grading them on how they address those 3 guided questions.
Okay, great advice. Sylvia and Sarah, you have just given our audience a lot to think about, a lot of really good information. Sarah, do you have some final points you'd like to make?
I think going back to this idea that doing science is great. I mean, kids need to be doing science, but the follow-up to that is that they need to be engaged in scientific discourse about that. That involves writing, that involves dialoguing, reading, all of the activities that help them bring their pieces and parts together. And that we do that in really authentic ways that are meaningful, hopefully getting to some of our unmotivated students and providing them an impetus to get interested in science. If I could leave anybody with that would be the thought, is great, let's do science, but let's also make sure that we are really engaging in scientific discourse about the science.
Okay, great. And Sylvia, what would you like to add?
And again, I think that coupling with Sarah here is that I think that we have to make sure that the students are doing science, they are making a connection of what they're doing, why they're doing it, and then giving them the opportunity that the first time round the writing may not be that great, But again, as they continue to write through the school year, they will become more comfortable with the terminology and they'll become better scientific writers.
Excellent. I want to thank both of you, Sarah and Sylvia, for participating in today's program and sharing your expertise with other science educators in the state.
Thank you, Terry.
Thanks for having us.
And thank you for your participation and email questions. In this webcast, we've discussed why writing in science can be a challenge, suggested some strategies for helping students represent their scientific knowledge, and suggested some techniques for using released OGT items to help students develop writing skills. We've just started the conversation about writing to represent scientific knowledge. Take advantage of the supporting materials found on Science Instructional Strategies, a look at the OGT homepage at www.ohioRC.org/4/science/OGT. If you would like to learn more about these topics, please contact ORC at web@ohioRC.org. We would be happy to work collaboratively with you to plan building or district-wide professional development programs. For the Ohio Resource Center, I'm Terry Shiverdecker, wishing you success with all of your science instructional strategies.